This is our last section before we start reviewing for your test next Tuesday. We've been working with exponential functions. All right, now we're going to look at how do we use some of those exponential, linear, quadratic, things like that, the different kinds of regressions to model some data. Okay, so we're starting out just with some generic pictures. Y equals 2 to the x. What does it look like? Okay, and I do want you guys to show me with your finger. Okay, draw the shape in the air. All right, everybody? Okay. So we should have a picture like that. What would we call it? What kind of graph is that? It's exponential growth. Yep. All right, so that one is an exponential growth curve. How about this one? What shape is it? With your finger. Draw it in the air. Yes? It's coming up like this? All right. And what do we call that? I'll give you a hint. You see it in the equation. What function is in that equation? A log? Yep, this is a logarithmic curve. Okay. How about the third one? General shape? Everybody? Yeah. And it should go right through the origin, right? It's just cutting quadrants 1 and 3 in half. That is a linear equation. Has a positive slope? Yes? Okay. Looking at the bottom three. First one, draw the shape. First one. Should look like that. Should be coming from high and going down as you go to the right, leveling off the x-axis. What kind is that? Yeah, it's exponential, but this time around it's a decay curve instead of a growth curve. All right, next one. It's another logarithmic one, right? It's got a natural log in it, but instead of coming up along the y-axis and curving off to the right, it's coming down from up on top, coming down along the y-axis and curving off to the right. Okay, so again, it's another logarithmic one. It's just been reflected over the x-axis. Okay, and our last one should just be that -1 sloping line right through the origin. So it's linear again, but this has a negative slope where the one above it had a positive slope. Okay, so what we're going to be doing is we're going to be taking a set of data and we're going to be making scatter plots so we can see a picture of all the dots plotted. And then we're going to decide, does it look exponential? Does it look logarithmic? Does it look linear? You have other options. I mean, there are quadratic regressions, there's cubic regressions, there's quartic regressions, there's all kinds of things, but we're going to focus mainly on these. All right, so I need you to grab your calculators. We want to clear some things out of there before we get started. So the first thing I want you to do is to go to your y equals screen. If you have any equations in there, let's clear them out. Okay? All right, now go to Stat, Edit. Stat, Edit. And if you have data in your lists, remember you can arrow up to the list name, that heading, hit clear and arrow down, and your numbers will clear out of there. Okay, so you just want empty lists. All right, for our first one, we are going to put our age in list 1 and the percent of an adult-sized brain in list 2. What you're seeing in this chart is, for example, at age 1, a child's brain is about 30% of the size of an adult brain. Does that make sense? So as the child ages, the brain is getting bigger. Yes? Okay. So by age 11, it's almost a full-size brain, even though I wouldn't call an 11-year-old an adult. Okay? So take that couple seconds here. We're going to enter in list 1 our ages. And then over in list 2, put the size of the brain. You do not have to write it as a decimal. It can just be left as 30. All right, we got it in there? Now, we're going to set a window so that we know we see the right data. So for my x's, what kind of window do you think we should set? How big do we need to make it to make sure we see everything? We could go 0 to 12. Some people like to go a little further, 0 to 15. You just want to make sure you can see between 1 and 11, right? All right, so let's say we go 0 to 12. And for our y values, if we go 0 to 100, will that work? Okay. And again, if you want to go a little bit more than 100, just so you have a little cushion on the end, you can do that. But it should be, as long as you can see all your dots, you should be okay. So go into your window. We're going to go from 0 to 12 for x's and from 0 to 100 for y's. And you'll notice on mine, I put the x scale and y scale at 0. That just means it's not going to put any tick marks in there. Okay? If you want to set, for example, your y's went from 0 to 100, you could make your tick marks go by 10s. All right? You just don't want them to go by 1s, or it's just going to look like a solid line in there. Okay? It can't graph that many tick marks in that little window. But for what we need, we don't really have to have the tick marks in there, so you can set them at zeros. All right, let's graph it. Sorry, I skipped a step. Okay, let's go back. I have mine set from last hour. Now, we need to tell the calculator we want to do a scatter plot. Okay? So go under second y equals. All right, select plot 1. Make sure it's turned on, so highlight the word on. Make sure you've selected the scatter plot picture. And make sure that you've told it your x's are in list 1 and your y's are in list 2. Okay? And then at the bottom, I usually select the little square symbol. You can use the plus symbol as well. I think the dot is really hard to see. All right, it's more obvious your shape if you have one of the other ones. So pick one of the other two, select that, then hit graph. All right, check with each other, see if you have a picture that looks like that. So the question now is, looking at this picture, what shape does it resemble? Does it look linear? What do you think? Doesn't look linear to me. Does it look like exponential growth or exponential decay? No. Does it look logarithmic? Kind of. It looks kind of like it's coming up along a vertical asymptote and curving off to the right. Okay. So we're going to choose to think that it's logarithmic. All right. We're going to try to see if we can come up with an equation that would seem to fit this. Okay. So go back under your stat key, but this time arrow over to where it says calc. And then you're going to have to scroll down. There's a whole bunch of different regression options. Okay, so stat calc. Do you see number 4, linear regression? 5 is quadratic regression, cubic regression, quartic regression, another option for linear regression. And then LNREG, right? Logarithmic regression. If you scroll down, you'll see some others. You've got exponential, power. We've got lots of different options. Logistic is not the same as logarithmic. Okay? All right, so we're looking at option 9 here, a logarithmic regression. Select that. And now, if you have the newer calculators, it says X list, Y list, store, calculate on yours. Okay? I'm going to tell mine to use list 1, comma list 2. That's how I set it up on the older versions. And then I want to store the equation in my calculator so that I can see the graph of it without having to type it all in. Okay? So on the newer calculators, go down to where it says store. And we're going to tell it we want it to store it in our Y1. Okay? So to do that, we hit the variable key, which is right next to your clear key. Okay? It says vars, V-A-R-S. Hit that. Arrow over to Y variables. and then choose the first option. We want it to be a function, and we're going to put it in y1. Okay? So now when you hit enter or calculate on the newer versions, it's going to give you the equation, but if you look in your y equals, it's already dumped the whole thing in there. All right, and you're going to have a lot of decimal numbers with this, so it's nice to not have to type it in yourself. Okay, so when I hit enter, you should be getting a screen that looks like this. All right, at the top of the screen, they give you an equation, the basic generic one, and then they're going to tell you what to use for your A's and B's. Okay, we're going to round to 3 decimals. Okay, so it says y equals a plus b natural log of x. A is 31.954, and then plus 28.947 natural log of x. That would be the equation that I would write to represent that data. Okay? Okay, at the bottom you will see an R value. The closer you are to a positive one or a negative one, the better the fit. All right, a 1 and negative 1 mean a perfect fit, just a positive sloping versus a negative sloping option. Okay, but if we're at something like this, 0.99028, that's a really good fit. Okay, means our dots are going to fit our equation very well. If you're getting a regression value of like a 0.7, I'd say you picked the wrong model. All right, maybe it wasn't logarithmic, or whatever model you picked didn't work. Does that make sense? So you want to look at that R value. If your calculator's missing the R value, you're going to go second and the 0 key. It says catalog above it. All right, so second and the 0 key, which is catalog. And you want to scroll down and select diagnostics on and hit enter. Okay, that'll turn them on so the next time you do a regression, they'll pop up. It won't give you the R value for the one you've already done, but it'll be in there for the future ones. Okay. All right, our second set of data. So we want to go back to clear our old data out of there. We want to clear our y equals equation out of there. Oh, I forgot to show you the graph. Hang on. Remember how we stored the equation we came up with in our calculator? Well, if you hit graph again, it's going to draw it in, and you can see that the dots in the curve fit pretty well, right? We had a very strong correlation there. Okay? All right, now go to y equals. Let's clear it out, that old equation, and let's go to stat edit, and let's clear out those lists. Okay, I'll give you a couple seconds here. Go ahead and put women's age in list 1 and percent of miscarriages in list 2. All right, once you have the data in there, you want to select what kind of window. I would say that's a very, very common mistake. Students come up and say, well, I can't see it. It's because you're not looking in the right spot, right? So based on this data, what do we do for an X window? What do you think? 0 to 50 or even 0 to 60? Give us a little leeway on it. What about for Y's? Same thing? 0 to 60 would work? Okay. So let's go in and change our window. We're going to go from 0 to 60 for both of them. All right, once you graph it, you should see a picture like that. Yes? All right, so what do you think? Based on the shape, what kind of model do you think we should use? Looks like exponential growth? Okay, so let's choose to do an exponential regression this time. So we're going to stat over to calc. Okay, stat calc. And this time we want to scroll down and find exponential regression, which is the 0 option. Okay. So select exponential regression. Again, we're using list 1 and list 2. And let's go ahead and store it again. So go to store, then hit variables, y variables, function, y1, and hit enter. All right, what's the R value for this one? I'm getting 0.9726. So pretty good fit. We're close to 1 there. All right. Take a minute and write out the model. We're going to go to 3 decimal places. So based on what you see on your calculator, write your model out. All right, checking your model. I have y equals 1.194 times 1.081 to the x power. We good with that? Okay, go ahead and hit graph again. I want you to compare your curve to the data that you had in there. Does it seem like it's a good fit? It's not perfect, but it looks pretty good. Yes? Okay. I need you to grab a book and turn to page 501. We're going to do a couple examples from in our book. All right, so looking at example 5 in your textbook, page 501, it says the first figure, which is a histogram, shows world populations in billions for 7 selected years from 1950 through 2010. And then to the right of that, you have a scatter plot, and it's saying, give me 2 possible types of models I could use. What's one option based on the way the scatter plot looks? It might be an exponential growth. It seems to have a slight curve to it from the data we're looking at. Yes? Okay, so exponential growth would be a good option, but it's a very gradual curve, so it is possible it could be linear, and we're just seeing a little variation from that line. Okay, so for example 5, we're going to say it could be linear or exponential. Okay. Now, look at the data they're giving you in example 6. It says we have data for world populations. You'll notice some of the data is listed in a table, and then they've already done 2 different types of regression. They've done a linear regression, and they've done an exponential regression. Okay? First question says, well, let's look at the R values before we start. What do you notice about the R values for the linear and the exponential one? Are they pretty good? Yes. So from that, it's hard to tell, well, which is the better model? All right, is the exponential one better or is the linear one better? Because both of them are a really good fit. Okay. Part A, it says use the figure 4.28 to express each model in function notation with numbers rounded to 3 decimals. So go ahead and write out the equation based on the little screenshot of their calculator. All right, so for the linear one, we have y equals 0.074 times x plus what? 2.294. Okay. For the exponential one, what equation would you give me? Y equals, go out to 3 decimals and round. So y equals 2.577 times what? 1.017 to the x power. We good with that? Okay. Then it says in part B, how well do the functions model world populations in the year 2000? Go back to your table. What's the X value for the year 2000? Looking at the table in your book, it says the X's are the years since 1949, right? So when it's the year 2000, what did we really enter in the table? 51. So what we're going to do is we're going to let X equal 51, and we're going to plug it into both the linear and the exponential model and see what we get. Okay? So if you're on this side of the room, you guys use the linear model. Over here, you guys use the exponential model. Okay? See what you get for the Y value. All right, so what did we get for the linear option? Our Y value came out to be, what did we get? 6.068. Okay. And somebody else, the exponential one? Okay, so both really close. And what did it tell us in the table for the year 2000? It said 6.1. So both models right now are looking really good. Yes? Okay. Then part C says, one projection shows the world population is expected to reach 8 billion in the year 2026. So let's calculate for that year. In 2026, well, the year 2000 had an X value of 51, right? So what would our X value be here? Okay, so we're going to plug 77 in, all right? So you can recall the previous equation you just typed in and change your 51 to 77. And what do we get for Y values? All right, linear gets us 7.992 for Y, and exponential 9.43 something. Okay, so we were supposed to get something around 8, right? So based on that, which model is better? Yeah, the linear is getting us close to what we want, whereas the exponential one is pulling us too far away. So again, what we're seeing we had some dots that might have looked like they curved a little bit, but the exponential growth curve would have pulled this way up here, where when we're really looking at these, we should have been looking at a linear model. All right, that would get us to that 8 million instead of up here at 9. Okay, does that make sense? So sometimes you have to look beyond the data you have and see which one is going to continue to fit it better. Okay. All right. Your assignment. I'm going to have you read before, well, I get the assignment up here. I want you to look at question 72. Read through what that says. I put on here you're going to do 47 to 52, 66 to 71 part A, and then you're also going to do 72. But in 72 it says go back and redo 47 to 52. Well, I don't want you to redo it. I don't want you to go back and have to retype all that data in your lists. So in 47 to 52, it's asking you to graph it and pick the model, okay? And then it says move on to the next question. But now in 77, it says, okay, go back and actually give me the equation for that. So as you're going through the assignment, look at your picture, pick the model you think is best, get me the equation. Does that make sense? All in one. Then you don't have to re-enter data. Okay. So again, you're going to be doing 72 along with these, right? That's all together. And then just do the 66 to 71A separate.